All right, so today we are going to be talking about independent and dependent events. Today we're going to focus mostly on the independent ones, and on Monday we'll cover dependent events. But just so you know what they are. If the events are independent, then the outcome of one event does not affect the outcome of the other event. So, outcome of one event does not affect the outcome of another. Event. So the outcome of one event does not affect the outcome of another event. If it's dependent, then that means it depends, right? So the outcome of a second event depends on what the first event was. The outcome of the second event depends on the outcome of the first event. Okay, depends, dependent, right? Make sense? All right, so like I said, we're just going to do problems involving independent events for today. And then Monday we'll cover the dependent events. So the probability of independent events that A and B occur, you just multiply them together. Just like we did when we were finding all the possibilities for license plates. Now we're just turning it into a probability problem. So really this is stuff you guys already knew in a way. All right, so a class sells 150 raffle tickets for a mall gift certificate and 200 raffle tickets for movie passes. You buy 5 raffle tickets for each. What is the probability that you will win both prizes? So I'm going to figure out the probability for each of them and then multiply them together. So the probability that you're going to win the mall gift certificate. How many tickets did you buy? 5. Out of how many tickets total? 150. And then you can just reduce that to 1 over 30. The probability that you're going to win the movie passes, you also bought 5 of those, but they sold a total of 200. And so then that would reduce to 1 over 40. So the probability that you would win both is just multiplying those together. 1 over 30 times 1 over 40. So you only have a 1 in 1,200 chance that you will win both of them. So maybe you should have just bought 10 raffle tickets for one of them, right? You would have had a lot better chance of winning. All right, you guys figure out, though, what's the probability. Actually, let's talk about this one. We'll work this one together. I'm not going to make this a whiteboard one. They're grouped together. Let's take that off. Okay, what's the probability you'll win a mall certificate but not a movie pass? All right, so again, we already figured out the probability for the mall up here, right? But now we got to figure out the probability that you will not win the movie pass. So you have to think about it in the opposite way. How many tickets did you not buy out of the total 200? You didn't buy 195 of them. Somebody else bought those, right? And so, so the 195 over 200, that reduces to 39 over 40. And so the probability that you would win only the mall certificate, would be the 1 over 30 times 39 over 40. And 3 goes into both of those. Oops. 10. 13. So when I multiply, I get 13 over 400. So you have a lot better probability of at least winning one of them. Questions? All right. Problem number 2. In a BMX meet, each heat consists of 8 competitors randomly assigned to lanes 1 through 8. What's the probability that a racer will draw lane 8 in 3 heats? So in the first heat, how many lanes is he going to be in? Well, he has 8 possibilities, but he's only going to be in one of them, right? So the probability is 1 over 8 that he'll get lane 8. What's the probability in the next heat? It's still 1 out of 8. And in the next heat, it's still 1 out of 8. So you just multiply those together, and the probability that he will get it every single time would be 1 out of 512. So how about, I'm going to let you guys do this one on your own. A spinner is divided into 10 equal regions numbered 1 to 10. What's the probability that the 3 consecutive spins will result in perfect squares? So how many perfect squares are there from 1 to 10? I hear 1, I hear 2, I hear 3. What is 1 squared? What's 2 squared? What's 3 squared? How many are there? There's 3 out of. Okay, this shouldn't take you long to figure out. All right, so what are we multiplying? How many choices did we have out of 10 the first time? We had 3 out of 10. What about the next time? We still had 3 out of 10. And the next time? We still had 3 out of 10. So it would be 27 over 1,000. Any questions? All right. So we can use the complement to find probability also, just like we did before. All right, so we're listening to a CD with 16 songs, and it randomly plays 4 different songs. What's the probability you will hear your favorite song at least once in 5 days? All right, so if I think of all the ways that I could hear it at least once in 5 days, I could hear it once, twice, 2, 3, 4 times on one day. I could hear it 1, 2, 3, 4 times on the next day. I could hear it 1, 2, 3, 4 times on the third day, etc. A lot of different ways, right? So instead of adding all those up, what's the complement to that? That I never heard it, right? That I didn't hear it at least once. So instead of figuring out the probability of hearing it all those different ways, I can figure out the probability of not hearing it. And then just subtract it from 1. So on my CD, how many of the songs are not my favorite song? 15 of them, right? So I could do 15, choose 4, or again, you could just do 15 times 14 times 13 times 12. But the total songs on the CD, I have 16 of them, and of those I'm going to choose 4. So when I do that, it comes out to 1365 over 1820, which actually reduces to 3/4. So that's the probability of not hearing it just on one day. But I've got 5 days that I'm talking about, right? So the probability of not hearing it for 5 days, I multiply them together. I take the 3/4 for the first day. I've got 3/4 the next day, 3/4, 3/4, 3/4. I multiply them all together. So the probability of hearing it at least once in 5 days is going to be 1 minus that 3/4 to the 5th power. So 3/4 to the 5th power comes out to 0.27 or 237. So the probability of hearing it at least one time is 0.763. Okay. Questions? All right. So what if the CD only had 12 songs on it? What would you do then? Okay, so this time I did it just using the numbers of songs that are on the CDs, and it's actually a whole lot faster than doing the combinations. Because I have 11 songs that aren't my favorite, so 11 times 10 times 9 times 8 for the possible ones that aren't my favorite, over 12 times 11 times 10 times 9 for all the possibilities. Most of the fraction cancels out. You're left with 8 over 12, which is 2/3. So when I raise that to the 5th power, it comes out to 0.132. And you subtract it from 1, and the probability is 0.868. Okay? Questions? All right, that's it for today.